Hey everybody, Jamie from the Marine Doctor's YouTube channel, and today we're going to be looking at another comparison video. Again, between the 8 and the 9.8 or slash 9.9, but what we're going to try to determine is which one is better on gas. So, I've got a graduated bottle, I've got my smart tack, and that's what we're going to use in order to figure this out. We're going to run the engines, we're going to see how much fuel is used inside that graduated bottle, right? From top line to bottom line, record the results for the time, and then make a comparison. Now, I have my suspicions on what's gonna happen, and I hope I'm right at the end, but if you guys have predictions, put them down below in the comments. See if you guys are actually right. All right, let's get to the testing. So the ending of this video will be something a little bit different. I'm probably gonna do a sit down at home because we're gonna have to go through some data.
Take 14. This has been tough to get through. Okay, Mercury 8 horsepower versus 9.8 horsepower fuel efficiency test. Okay, I've got the data. I've added some other variables into the data to give us a better conclusion of the experiment that we did. The results that you guys saw were pretty straightforward, but I wanted to spice it up a little bit. So, without further ado, here we go. All the conditions are the same with the engines. The only difference between the engines themselves is the carburetor, right? I inputted a 1,000-pound load. We know that it's a 9-pitch prop with a gear reduction of 2.08. The Mercury ran for 8.74 minutes on 190 milliliters of fuel. The Tohatsu ran for 8.21 with the same amount of fuel. Okay. We factored in a prop slippage of 25%. And what that means is the theoretical distance the prop will travel in one revolution is 9 inches. But with prop slippage, because the prop's not going to be 100% efficient, we factored in 25%. That gave us 6.75 inches per revolution. So for each time that prop spins, the theoretical distance it'll now travel, instead of being 9 inches, is going to be 6.75. All right. The next thing we did was calculated the theoretical speed. So we're doing 3,000 RPM times that distance that it'll travel of the 6.75 inches. We get 5.89 miles per hour. Now that's going to be consistent with both engines because they are the same and they're both doing this with the same load, doing the same amount of work. So that's the speed that we're going to get. We then moved up to 1 liter of fuel rather than the calculation originally done at the 190 milliliters of fuel. Okay. So the run time per liter of the 8 is 46 minutes and 5 seconds. The run time of the 9.8 would be 43.21 seconds. So we see a difference of 3 minutes of run time, which could be very important if you're trying to outrun a storm or what have you. You've got that little extra distance now that you're going to be able to cover at the theoretical speed that is given, or that we've decided with, or had decided with all the variables we've inputted. Now, the actual distance that you're going to cover, though, is going to be 4.52 miles with the 8 versus 4.24 miles with the 9.9. Now I also calculated the speed that you would, or sorry, the maximum speed that you would be traveling with both engines. The theoretical maximum RPM, for example, of the 8 is 5,000 RPM versus 5,500. Now, we're probably not going to see those numbers with the load, all right? But this is just an example of the speeds that we might be able to achieve. So at 5,000 RPM with the gear reduction and the theoretical prop size, we would see 9.8 miles per hour. The 9.8 at 5,500 RPM, given all the other same variables, of 10.79 miles per hour. All right, there's the results. Are they what you expected? Did you expect the 8 horsepower to be a little bit slower than the 9.8? Probably. Did you expect the 8 horsepower, though, to outdistance the 9.8? That was surprising. My prediction is this. I thought that both engines would be closer than they actually are. Yes, they are very close. Now, the reason that I thought that they would be closer would be I thought that with the same displacement of the engines, and the only difference being the carburetor, we would have to run the carburetor open more on the 8 to allow for the same amount of fuel to be drawn in to create the same amount of power that the 9.8 delivers. But that doesn't seem to be the case, and the research that I've done since shows that at any given RPM, the 8 horsepower should burn less fuel. Although the 9.8 will always create more power at full throttle than the 8 horsepower is capable of. Who'd have thunk? Anyway, I hope you guys' predictions were correct, and if not, then you've definitely learned something. Here's another video showcasing the same engines. I swapped the carburetors on. You can go ahead and see if it makes a difference. I believe I was running the 8 horsepower, and I ran a 9.9 horsepower carburetor on it to see if it makes a difference. But yeah, have a view of that. It's good content. I enjoyed making that as well, and I will see you guys in the next video. Thanks for watching.